Alright guys, so in this video we're going to be talking about the differences between high, medium, and low level programming languages. Now when we're talking about programming languages, what does the high, medium, and low refer to? What do those mean? Those terms mean? Not level, language. So the high, medium, and low, that refers to how far up or how far away the programming language is from another language called machine code. Machine code. And machine code, those are the ones and the zeros, the bits that people think about when they think about programming. Now these ones and zeros, this machine code, this is a digital representation of an actual physical device. And so what does that mean? Well, these ones and zeros, they represent an actual physical piece of hardware called a microtransistor. And there's thousands of them on your CPU. The cool thing about a microtransistor is that it can represent two different states, an on state and an off state. And so you may have also heard that your computer is just a large calculator, that all it does is crunch numbers. What if we wanted to create a number system for the computer to crunch? What numbers would be in that number system? How would we go about evaluating the numbers in that number system? Well, if we were to, say, create a number system based on a limit of the microtransistor, and so this microtransistor can represent two states only, a binary option. Not 4 states, not 16 states, not 1,000 states, simply 2 states. And so if we were to create a number system based on this physical limitation here, we would have the rudimentary beginnings of a base 2 or a binary number system. So a number system with two choices, an on or an off, or a 0 or a 1 or a 0. Well, this is great, but how would you go about representing complex calculations with only the numbers 0 and 1? How would you even represent the number 4? Or 128, or 232 with only the numbers 0 and 1. Well, it turns out that if we string together 8 of these bits, if we group 8 transistors, microtransistors, 1, 2, 3, 4, 5, 6, 7, 8 bits, we now have what we call a byte. 8 bits in 1 byte. And so why did we group up 8 bits in 1 byte? Well, if we group up 8 bits into 1 byte, and we evaluate all of these bits as one value, we've essentially expanded or increased the range of our number system. And so let me show you what I'm talking about. And so before I explain this, we need to go over two terms, the idea of state and the idea of value. And we need to differentiate the two. That state is not always value, value is not always state, but that they can sometimes be the same thing. And so when we were looking at 1 bit, this 1 bit represented 1 microtransistor. We could say, and we did assume, that its state was also its value. And so let's say this microtransistor was on, we would give this bit a value or a state of 1. We could also say that the value of the bit was 1. Conversely, if the microtransistor was off, we could give the bit a state of 0, and we could also say that the value of the bit was also 0. However, when we're stringing together 8 of these bits, we need to separate the idea of state and value. And so each bit can stay with the definition of a state. If the state of the bit is 1, that's an on. If the state of the bit is a 0, that's an off. But the values of the bits change. Now, how do we determine the values of the bits? Well, we use this little formula, this little function here. F of n is equal to 2 to the power of n. Base 2 because we're in a base 2 system, and the n is an arbitrary variable. It could be an x, it could be a b. And what this n is mapped to, it's mapped to the index of the bit, which brings us to two more terms that we have to differentiate. And that's the idea of position versus index. And so in programming, position is not index. Index is not position. Position is what most people think about when they think about grouping terms. And so this is the first bit here. We'll go from right to left. This is the first bit here, so it's position 1. And position 2, 3, 4, 5, 6, 7, and 8. However, in programming, we start at index 0, not index 1. And so this would actually be index 0, 1, 2, 3, 4, 5, 6, and 7. And so we have positions 1 through 8 and indices 0 through 7. You take the bits index, you plug it into our little formula, and you get the index or the bits value. So let's do an example. How about we turn on the 4th bit, which is index 3. So give it a state of 1, and we turn off every other bit. 0, 0, states of 0, states of 0, state of 0, state of 0. Now, we go through right from left, and we evaluate each bit, and if the bit is on, we take that value. If the bit is off, we don't take that value. And so let's start from right to left. The first bit with index 0, its value is 2 to the power of 0, which is 1, but the bit is off, and so we take a value of 0. Same reason for bit 2 or index 1, same reason for bit 3 or index 2. When we get to bit 4 or index 3, the value of this bit is 2 to the power of 3, which is 8. The bit is on, and so we take its value. And then these guys are 0 for the exact same reason that these guys are 0 here. We'll add some addition signs, make an expression. We'll add our equal sign, make an equation. We'll evaluate the equation as 0 plus 0 plus 0 plus 8 plus 0 plus 0 plus 0 plus 0 gives us a value, a total value of 8. And so we went through a base 2 system with a range of 0 to 1. And by grouping up 8 bits and treating them as one evaluation, we've extended the range of we're still in base 2, our binary system, from 0 to 255. Now why 0? Well, if you give all the bits a state of 0 and then you take their values, you get 0 plus 0 plus 0 plus 0 all the way through. That gives you a 0. Now why 255? Well, if every bit is turned on, you get 2 to the power of 7 plus 2 to the power of 6 plus 2 to the power of 5, 4, 3, 2, 1, and 0. When you add all of this, you get 255. And so now we went from a number system with 2 choices to a number system with 256 choices. All right, so what did we do? We took a base 2 number system, and now we're able to represent numbers in a base 10 or a decimal number system. We've essentially abstracted up a layer. What if we abstracted up one more layer? What if we used a base 10 or a decimal number system to represent a different system? And in the system, we had things like letters, other numbers, symbols. What would that system look like? What would that system be called? Well, that system would be called an Ascii character set. And so let's do a paste. Yeah, increase this, zoom out a bit. Let's move over. So the Ascii character set or Ascii character system, let's zoom in a bit. What this does is it takes letters and symbols and other numbers, and it maps those letters, symbols, and other numbers to a base 10 or a decimal number system. And that decimal number system is, of course, as we saw here, is mapped to a base 2 system. So let's take an example. Let's go with an R. And so we see here that the ASCII character R is mapped to the decimal or the base 10 number 82. And the base 10 number 82 is mapped to the binary or base 2 system number 010 10010. And so why did I show you all of this? Zoom out a bit. Why did I show you that we took a physical device with an on or off state, right here, a microtransistor, we mapped it to a digital form with a 1 or 0 state. That's our binary or base 2 state. We took that base 2 state and we mapped it to a decimal or a base 10 state. And then we took the base 10 state and we mapped it to an ASCII character set of letters and numbers and symbols, hashtags, dollar signs, things like this. Why did I show you this process? Well, All of this just to say that when you're programming, there's layers or levels of abstraction happening. There's layers moving up and layers moving down. So how does this solve or answer the question of the video? What is high, low, and medium? Where do those terms come from? Well, if you see here, the machine code sits right next to your microtransistor. This is because machine code, or programs written in machine code, have the ability to directly manipulate the hardware. And so programming languages that can directly manipulate the hardware are said to be lower level programming languages. Programming languages which can't manipulate the hardware directly are said to be higher level programming languages. So with that said, let's take a look at a description of a low level programming language. So let's do can we do a paste of a node? Let's add a node, we'll do a paste, and let's drag the node over here. All right, that a bit, let's tilt it a bit. There you go. So this is a little description of a low-level programming language. Now, low-level programming languages are platform dependent. What does that mean? Well, some cars are built specifically for a diesel engine, and so their physical makeup restricts what can and can't be done with the car. So similarly, some types of CPUs differ from other types of CPUs. And so machine code written for one type of CPU will not work for a different type of CPU because of the different hardware makeup. Low-level programming languages are syntactically cryptic. Think about reading pages and pages of zeros and ones and how strenuous that would be on the eyes. And so for this reason, low-level programming languages are said to be syntactically cryptic. Now, they are directly executable. What does that mean? Well, if you remember up here, the machine code sits directly right next to the hardware. And so programs written in machine code don't need to be translated into machine code because they're already machine code. And so programs written in machine code are they can run directly without any translation and manipulate the hardware. And because of this, they are also more efficient. Now, let's go to high-level programming languages. Let's do a paste. Let's zoom out a bit. Let's throw this guy here. Yeah. This would be for high-level. So high-level programming languages, they're compiled and or interpreted. And so high-level programming languages are written in things like Ascii Character Set, and as we saw, it would need to be, in order to get to machine code, it need to go down to base 10, down to binary, and then it could run on the CPU. And so the process of compiling and or interpreting will look closer into that, I think, in the next video. But just to say that there is a translation process that takes place in higher level programming languages. Now, because there's a translation process, programs written in higher level programming languages are platform independent. And so you could write source code on your Mac computer, and with a Windows compiler or interpreter, you could translate that source code into a Windows machine code. They're also syntactically simpler, and so that's a bit obvious. It's easier to read A, B's, C's, and 1, 2, 3's and symbols rather than just zeros and ones. There should be a T here. Because they are compiled and or interpreted, there's some translation, there's some time needed. And so for that reason, higher level programs written in higher level programming languages are less efficient than ones written exclusively in machine code or lower level programming languages. And so medium level programming languages are what you would expect, that they're a mix between high and low level. Medium level programming languages have the ability to control hardware directly. So things like C or C++. They're less syntactically cryptic than zeros and ones. You actually write in Ascii character sets. You can also write in memory addresses, so numbers. They're compiled or interpreted, so they're not as fast as lower level machine code languages, but they straddle the in between. They're less efficient than low levels, but they're more efficient than high levels. And so a medium level programming language like C would be exactly what you expect it to be, a hybrid of low and high level descriptors. All right, well, we covered a lot in this video. I don't plan on making videos this long. It went over 10 minutes. I plan to make 10 minutes or less, attention spans and all that. And so let's end this video by summarizing the last video and this video, what we should have a general understanding of. And so if we take into account the last video, we have an idea of what programming is, which is just data manipulation. Data manipulation. We have an idea of what a programming language is, and that's just a way to communicate with the computer, to tell it how to manipulate data. We have an idea of why programming languages are a thing. It's a pain to write program languages in zeros and ones, and so we had to invent a way to write in things we understand, a more human-friendly, readable language. We understand where modern programming languages come from, the idea that we're limited by physical reality. We translate this physical reality into a digital reality of zeros and ones. We go from a binary to a base 10, and then a base 10 into something more human-friendly, the Ascii Character Set. And we have a general idea of what the differences are between a low level, high level, and then in between the medium level programming language. And so the next video we'll be taking a look at, I don't think we're going to do actual programming in the next video. We're going to stay a bit more abstract. We're going to take a look at the JavaScript programming language. We're going to take a look at its whether or not it's a high, medium, or low, what that means, is it compiled, is it interpreted, how it's used for web development. So I will see you guys in the next one.